Okay, so let's say we have this problem when you're an astronaut and you have to push a pair of boxes all around the place. And well, what you have to do here is you're applying a force like here, that's force A, and well, this force is that goes directly into the mass one, but mass one exerts a force directly to mass two. But the irony is that mass two also exerts a force on the other side. Okay, so pretty much we have to do two force diagrams. The first one is going to be for mass 1 and the second one is going to be for mass 2. Okay, so let's start with this. I'm going to call this 1 and the other one I'm going to call it 2. For 1, we're going to start with this and well, I'm going to say that for here, the sum of all the forces in the mass one in X. I don't have in Y, so I don't have to do it. So I got the force that I'm applying and the mass of the second box. That's the force. I'm gonna call it the force. The one is going on 2, and if it goes the other way, is the force that 2 makes on 1. Remember relative things. So I'm gonna call it minus the force on 2. The 2 brings on 1, and it's gonna move, so it's gonna be equal to mass times acceleration. Okay, so that's for 1, and for 2 it's gonna be like pretty much similar. That's mass 1. Sorry for that. So the sum of all the forces in X is gonna be, well, pretty much just the force that 1 exerts in 2, and that's gonna be equal to mass times acceleration. Okay, so there we go. Now, from there, I just know that this is exactly the same force that's going there, but on the other side. Okay, so I just can substitute it and plug it on the other way. So I'm gonna do that, and it's gonna make my life far much easier. So I gotta have this force that goes this way minus the mass of the box 2 times the acceleration, and this is gonna be equal to the mass 1 times acceleration, and I need to find the acceleration of the boxes. So for doing that, I just need to solve for A, and that is like force. It's equal to mass 2 plus mass 1, all of that in a big parenthesis, and that time acceleration. So acceleration is going to be equal to force over mass 1 plus mass 2, and you just substitute the values and just know that this is 12 over 3 plus 2, and that is equal to 2.4 meters over second squared. So there you are. Now that's part A. Let me just like write it here. For part B, let me change colors for a blue. Okay, so we just now need to know the magnitude of the box. So we know it from the second equation. So we know that the force 1 and 2 is going to be the mass times acceleration. So from here we just know that the mass is in this case 3 mass 2, sorry, times acceleration 2.4, and this is going to be equal to 7.2 newtons.